So we can make a start. Good afternoon, everyone. Hopefully not too sleepy after a heavy lunch. What we're going to talk to you about today is the upcoming IoT cybersecurity legislation. Now, I know it sounds a little bit boring, but we're going to show you how you can build devices that can comply with those up-and-coming legislations. So, up here is the apps team. We're Jones and Keith from Crypto Quantique. And we're going to be presenting some solutions for you, and also Keith is going to be running through a demonstration, which you can come to the booth later on, and we can talk to you and show you it in a little bit more detail if you're interested. So Crypto Quantique, we're based in London. We're just behind the Tate Gallery. We've started in 2016. There's 40 of us, quite a mix of people, IC designers, PhDs in cryptography and quantum physics, and we do a lot of quantum physics research. Lots of software engineers and, as I say, hardware engineers. So we're not far from here. So I want to talk to you about security and why it's a big issue. I'm sure you've seen all the things in the news about people being hacked and the problems that it's causing. So here are some numbers that are bandied about. They're all pretty big. So here we've got 75 billion IoT devices by 2025. That's kind of like an unimaginable number, but it's big. So there is going to be a lot of connected products out there. So we do need to make sure that these are built safely. Legislation is here and coming. So up to 20 countries are introducing regulations. So it's not something you guys that are designing IoT products or connected products can continue to kick the can down the road. Legislation is coming, and you're going to have to start building secure devices if you want to sell them, in the EU or UK market. Costs of cybercrime, I mean, that's even a larger number. It's kind of unimaginable, but that was in 2021. I think the one that surprises me the most is this 50%, I know it's in 2020, but 50% of devices that were connected had known vulnerabilities in them. So they were just shipped knowing that they possibly could be hacked. And that's pretty scary. And these are the kind of things we're having to deal with. And hopefully we can show you how to solve them. So this is just sort of information for you, just showing you where the legislation is coming from. America was the first to actually put some legislation into law in California. Surprise, surprise. Where you couldn't sell a device in California that had a default password on the product, which is kind of the first classic hack. It's coming in the UK. They've been dealing with preparing some legislation for quite a few years now. And the PSTI bill is coming out. I've got a little bit more information on that. And then, of course, the EU, they're similar to the PSTI, but a lot more verbose, so a lot more words describing it, so as you'd expect from Europe. And then Japan and all these other countries are coming out with legislation. So it's a big deal, and we need to be aware of it. So in the UK, you'll see this DSIT. They're bringing out the legislation, and they begin to get their teeth on April 29th next year. So that's when they will be able to come after you and start fining you and preventing you from selling products. So that's when they actually told me that's when they get their teeth. The next one is European Union. So that's going to be later on next year. They're going to put a framework together for you to develop electronic components that are connected. And they've got quite a good set of documents to help you, classic EU, to help you get through it and know what you need to support. And as I said, the USA, always pushed by NIST, they're the guys that are doing quite a lot of standards, and they were the first to bring out an actual law against a connected product. So that's what's currently around today. So what do you guys need to know? That's all very nice. Somebody's going to come after you, but what can I do to help myself make a product? So the best thing to do to start with is to just get well read on it and what you need to do. So you need a good understanding of what the industry feels is good practices. So because making a secure product didn't have any legislation, so there was no sort of fines you could get and such like. It was pushed to design these products with the best practices. So a lot of people came out with these best practice documents which describe the things you need to think about when you're making a connected product. So it started out actually with this one here, Code of Practice, which was out 2018. And it's a great little book. It's a bit out of date now. But it's really quite a good read. It kind of just gives you a good overview of the sort of things you want to think about. It doesn't tell you the details of how to implement them, but it tells you the things that you need to think about. So that's been superseded by the one over there, which is the IoTF's Best Practice Guide. So the IoTF is a foundation that kind of runs a lot of this security stuff and puts all these best practices and has a lot of thought leadership in security. And I highly recommend their website. And now they've actually published this Best Practices Guide, which is kind of an enhancement to this original one. And that is worth looking at. So that's the one that will take you through each of the items and describe to you in a little bit more detail what the things you have to do. And then if you are selling products in Europe, then this is the European one in here, which is a lot of pages. But it kind of covers a similar thing to the one over there. So these are things you need to have a read about. I think you get these slides later, so you can get the links off them. So that's kind of like your Sunday reading down the pub. So what is it they teach you? So I'll just give you a quick flavor of what you get out of them. So the first thing they ask you to do is actually look at the data that's going to go through your device and then try and classify it. Sounds a bit boring, but it's just interesting to look at what sort of things am I sending a password somewhere? Is a password coming in? Is that personal data? What am I going to do with it? How am I going to ship it? Just kind of see what data you're dealing with and kind of classify it. So that's a good exercise. Physical security, so they talk about not putting anything that you use for backdoors in development in your end product, right? So no USB backdoors for you to gain access to the part and stuff like that. That's just everybody just goes straight for that sort of thing. Classic is to maybe draw 2 pins out and then put a little test pin on it and kind of, that's okay, that'll be on the PCB, that'll ship. But anybody who wants to hack your board, they'll go straight for that, put an analyzer on it, give it a bit of a tickle and see what comes out. Run your address bus under the, between the layers, all this kind of cool stuff, epoxy it if you can, all sorts of really cool stuff like that. Some of it's kind of crazy, but it gives you an idea of what you need to think about. So that's physical security. Secure boot, so you need to have some kind of secure boot on the device. That's kind of a given. There are lots of micros out there today that have that as a default. You definitely need to use a secure boot mechanism. It needs to be an immutable boot. Because it's a connected product, you're bound to be using some kind of OS. So make sure you've got the popular ones are out there used freely, things like FreeRTOS, Azure, Zephyr, that kind of stuff. Need to learn about encryption. So how do I encrypt my data? If there is some data I need to encrypt. What standards do I use? Make sure you use the latest standards. And something I was always told about in security is never try to hide what you're doing. So when you're doing security and you're encrypting something and you're using cryptographic keys, use the best standards that are out today. Don't try and say, oh, this is a cute little algorithm I found somewhere that somebody's written. It looks really cool. No. You use the best standards and the most common standards out today because they're the ones that have been tested. And if there's any cracks in them, you'll know immediately and you'll be able to close it down. So don't try and hide your security. Make sure everybody knows the kind of algorithms you're using. Network connections, so you're going to be connecting to cloud services. That's going to be TLS connections anyway, so it talks about that. And then, of course, software updates. You need to be able to do software updates in your product. You need to design that in straight away from day one. So those are things it will talk to you about in some detail that, I recommend you look at and it gives you ideas of what you need to do in your product. Okay, so what is the sort of the major problem that you're trying to deal with? So today's solutions make a complex problem even harder because the manufacturing flow is just so complicated. So this is just kind of an example of an IoT product, what it has to go through. So you'll get some kind of chip, you'll use a microcontroller or something to be the intelligence of the device. You'll need to program it somehow, so you'll need a programming house. You want to put some cryptographic keys inside to give it provable identity. So that means you need an HSM that's going to generate those keys. You need to get the keys from the HSM to the programming house into the device. That's maybe here where you're manufacturing, where you're putting your software in. And then all of these steps, these links, these are the things that are going to get broken and people are going to be able to get access to. So this is the kind of thing you have to deal with security. You have to know about all these entities. So let me have a bit of a delve into what is the problem of each one. So chip to cloud. So the first thing you need is to communicate with the cloud, you've got to have a secure encrypted channel. So you need a TLS link. You have to have that. So that's complicated because you need to deal with stacks, cryptographic keys, certificates, that kind of thing. So that's quite complex. Other things you need to do is you need provable identity. So the number one thing with security of a connected device is each device has to have a unique identity, and it has to prove it owns that identity. It's not just a number, right? So UUIC in an MCU is of no good. You know, I'm number 7, big deal. You need to be able to say, I am number 48, but here is my proof that I own that identity. So I have a private cryptographic key associated with it. So that's one thing you need. Very complex to get that in a chip. Identity keys, so these keys that are proving the identity, how do they get into the device? How are they generated? They need to come from a high entropy device, so they need to typically be created in an HSM. So that's quite expensive. You need an HSM. The private key is transported from the HSM into the programmer, into the chip, down a JTAG interface. Is it in the clear? Complex. You need a secure MCU. To protect and manage your keys, you need, as I said, these secure MCUs. So there's quite a few now on the market are coming out. The vendors are putting these security peripherals in them. And there's a lot out there. So Renesas, ST, NXP, Scilabs, all these guys have got some pretty cool secure MCUs. You need to be able to process cryptographic keys if you're doing a TLS link. So you need acceleration hardware. You need to be able to have the algorithms in embedded code. This is complex software. It is very complex, dealing with certificates and keys and communicating with cloud services. Believe me, it's pretty tough. So you need your application, and of course, at the end of the day, you need to run something which is your cool stuff. So you need an RTOS that supports these secure channels. So TCP/IP stack it's got to have TLS stacks, and obviously run an RTOS. So you want something that's well known, and it's quite complex to integrate that into your application. Then you need to connect to the cloud, which is making use of certificates and provisioning, and you have to get certificates into your device. Again, it's pretty complex and can be expensive. Then once everything's connected and you've got your device connected to some cloud service, you have to maintain it for all its life, right? So you have to do software updates, you have to renew the certificates, if there's a vulnerability, you have to revoke it and then reissue another certificate. That is a minefield. You have to get into public key infrastructures and things like that. So our little face at the end is it's difficult to do. So one of the things we're trying to do here today is simplify all this for you and do a lot of this work for you. So the solution is two things, really. So you have some kind of IP that provides a foolproof ID for the silicon chip. You can do that by either using a physical unclonable function or OTP that you program, or a secure element is pretty good at giving identity. And that's usually provided to you by the chip vendor. And then you need some kind of software package to actually manage this device throughout its life cycle. So you have to have something that can do the secure programming. You have to be able to update software on that device securely. We sort out the consumer brand, where you may want to transfer ownership of the device from one brand to another. And of course, you end up with your smart device, which is a connected device that has the capability to be updated. So you need a software that can provide you with a provisioning service, certificate management, and do firmware over-the-air updates, and do all this management for you. And it'd be nice if you could support lots of different secure MCUs, and if the embedded firmware to do all this complex stuff was kind of handed to you free. That would be great, right? Structures and things like that. So our little face at the end is it's difficult to do. So one of the things we're trying to do here today is simplify all this for you and do a lot of this. So this is something that is what CQ is all about. This is what our company is here to do, is to provide you with this stuff and make it as easy as possible for you to connect these IoT devices. So two of the main things that we have, two products, is a QDID. This is something we sell to semiconductor devices, which they put into their silicon chips, MCUs, etc. And that gives you this unforgeable fingerprint. So that gives you that identity. And the cool thing about it is you don't have to inject keys into this device. So that HSM programming house thing evaporates. So that's a lot of security issues removed immediately. And that's provided into the chip vendors. And then we have our QuarkLink, which is today we're announcing a free version, our SaaS model, QuarkLink Ignite, which I'll talk about. And this is providing you this security to onboard devices, do over-the-air updates, and manage the security of your device throughout its life cycle. So we solve all these issues with the programming house and transfer and your smart devices. So this chip-to-cloud capability that we're providing for you, it's automated, scalable. You have full ownership of your device. You're controlling your device. It's much lower risk because we provide all these tools for you, from the embedded software all the way through to onboarding to the cloud service. It's very low cost. And the important thing is the scalability. So we can onboard thousands of devices by management of the QuarkLink itself. So one of the things we wanted to do today was announce our QuarkLink Ignite. So this is kind of a version of QuarkLink that gets you guys started with this, so you can actually start to play with it and make an actual IoT device. So it supports at the moment the ESP32. A lot of people are kind of familiar with that. So that's the first thing we thought we'd support on this Ignite version. So you can come in and sign up to QuarkLink Ignite today. It's free. You can go in, you can play with the software, the onboarding. It will onboard you to databases, AWS, Azure, whatever you like, and it will do it securely with the ESP32. You can go to our GitHub, you can download all the source, add your application if you wish. The QuarkLink will program the device for you, and it will manage the onboarding of that device to a cloud service. And it does it securely. So your updates, if you change your application and you want to update it, it's done encrypted and it's done securely. And you can do those as many times as you want. And the Ignite version supports up to 50 parts as well. So you can actually build your own IoT ecosystem if you want. So you can get a really good feel of actually designing your product using this tool. And it just simplifies all those other complexities that I've talked about and will help you in getting your product legal, I guess. So this chip-to-cloud capability that we're providing for you, it's automated, scalable. You have full ownership of your device. You're controlling your device. It's much lower risk because we provide all these tools for you, from the embedded software all the way through to onboarding to the cloud service. It's very low cost, and the important thing is the scalability. So we can onboard thousands of devices by management of the QuarkLink itself. So we're going to do a demo. 3 things that you need to know now then is educate yourself, have a good read down a pub Sunday afternoon, have a look through those pamphlets, read about the up-and-coming legislation. It's not too bad. And try to follow these best practices. Gives you some idea of what to add to your design, and it's always also best to start putting in security day one of your design. Work with the semi-vendors, so use the latest secure microcontrollers out there. There's some guys today which will promote some of the newest ones. ST have just released the H5. That's a pretty cool chip. Renesas's RA6 series, microchips, secure elements, all good stuff. Try to use the latest ones. And then start using secure solutions. So start with companies that really understand the importance of security. So guys like us can help you with this. And only solutions on the market covering both IP and software. So demo time. So my esteemed colleague, Keith, now will take you through.
One more slide.
Yep. We'll take you through the process of showing you how easy it is to use a QuarkLink to connect to some kind of, I don't know, database or an MQTT broker. So this is just really the setup we've got. So we've got a ESP32 device here. It's going to go through his mobile phone hotspot because the Wi-Fi here is awful. And what we're going to do is use the QuarkLink to connect this device to, is it a database we're going to do? MQTT broker, so that you can start publishing data to a broker that's local to the QuarkLink. So, so I will hand over to you, Keith.
Yeah. A second to get rid.
So this is what you'll see when you sign up and log in to your own QuarkLink.
Hopefully you won't see my password. Stop talking. I have to make it secure because otherwise I'll be a hypocrite. There we go. Right. So this is, the QuarkLink GUI. We have a dashboard with a number of devices. I'll be talking about the different bits as we go through. And we're going to talk about provisioning securely this little device. It's got a cyan blue LED at the moment. It is out the factory, comes straight out of this box. It does have ESP Rainmaker on it. We're going to flash it securely and enable all the secure features to make it our own device. So the first thing we're going to do is create an IoT hub for our device that we want to connect it to. I've got a couple of examples here. Demo AWS, so we've got products that we connect to the CQ AWS account, but we're going to create our own one here, and I'm going to call it Demo MQTT because I can't think of anything else. And then you can see here we've got a number of supported options. We're just going to publish to a local, in this cloud instance, MQTT broker. So there's nothing more to fill out there. We'll just save that in there. So that's our hub that's going to connect to the cloud. We then need to set up a policy. So when our device connects, we know what security policy to give it. I've got some here. 1 day, 1 hour life cycle. We've got AWS example. We've got a demo provisioning policy already running. I'm going to create a new one for us today, and I'm going to call it demo policy. Makes new glasses. It doesn't actually matter what you call it. It's just a unique name that you can refer to. And then we're going to set our connection. So we're going to connect either to an IoT hub, being Amazon or Azure, or a direct database connection, which is for another day. We're going to talk to an IoT hub, being MQTT, and done it in the wrong order. No, that's right. Demo MQTT, that's my hub I just created. Good. We're going to leave the keys, certificates for default for 1 hour, for 1 day. That's fine. We can choose shorter periods and we'll just renew them more often. So that's our policy. And now we just need to know what device we're going to connect. So we haven't provisioned our device yet, but I'm going to give it a batch that I want to put it into so that I know I created it today and there's no magic going on behind the scenes. So who can guess what I'm going to call this? I can't. Here we go. A demo batch. And we're going to use our policy, demo policy. This is why I named it, nice and simple. We could create a new one here, but I've done it already. We're not going to apply firmware now. We're going to leave that blank. We'll come back to that, and it will become apparent. We're not going to add a device because we're going to do it securely via QuarkLink. So we have our batch, we have our policy, and we have our hub set. So now we're going to go to our provisioning task, and we're going to set up a new one. So, demo task. We're going to pick our device. We've got two devices, ESP32C3, which is the recent secure ESP device that they've announced. We've also got the M5 EduKit, which is the M5 stack. If you come by our stand, you'll see these lovely yellow boxes with displays on them, very pretty and flashing lights. Always gets people asking us what they are. we're going to use the ESP32C3. We're going to pick the bootloader. So we've got a couple of revisions there and development or release builds. We're going to pick development because I want to be able to reuse my devices. And again, for the initial enrollment firmware, so we have the IEF firmware that's going to provision our device securely. It's going to generate the keys, enable secure boot, and get it uploaded and get that unique ID ready for QuarkLink to use. So we're going to pick the latest version there.
This is the software that is on our GitHub that you've got the source for, so you can play with this and build it yourself.
And then I'm going to pick my own provisioning key because I want to be able to reflash these boards and not keep an eye of everything else. But we could create a new key here, demo key, and you can see the options. We can create an elliptic curve, secure, digitally signed key, or we can pick an RSA key. For the initial enrollment firmware, we need an RSA key, and we can see we've got 3,000 bits, so it's quite a large key. But we're not going to use that. We're just going to pick my...
So this is the important bit, because as soon as we save this key, that key is stored in a cloud-based database, HSM. Nobody can ever see it. But that key now is going to be blown into that device, and you can't do anything with it afterwards unless you've got that key. So, and this is kind of unique to this kind of system. So once Keith provisions that device, that's it. Anything you ever do with it in the future, you've got to use that key. So it's truly secure.
Here's my task. There it is. So we're going to run this task. Can't believe we're doing this live. Oh, I can't believe it hasn't saved my network name. Oh, QC Frank. And my network password is here. No, this is being recorded as well. Oh, the irony. There's my network password. And I'm going to stick this device. When it's provisioned, it's going to go into my demo batch. That's where we want to stick it. So we know it's all happened live today, now. So we start provisioning. What's it going to do? It wants to connect to the device. So we're doing this locally, obviously, via USB. So we connect through the power of Chrome to my device. Connect. QuarkLink is now going to connect, download the bootloader, set secure boot, get that identity, set the eFuse bits to make sure that they're set, extract that key, get that partition table, set the initial OTA data, and download that initial enrollment firmware from the cloud that we selected in our settings. That's all done. I'm going to reset. That's new.
Just the partition table. So it's blown the key in. So that's it. We're now a secure device.
There we go.
It's configured.
Device
It's
configured.
produced this unique identity. You remember I mentioned this identity? So it's created it. Okay, it wasn't number 48, as I said before. It's actually quite a big number.
Very big
But this device is now capable of proving that it owns that identity. That's the trick. And that's all been done locally by the QuarkLink.
So now if we look at our devices, we'll see that it's not been enrolled yet, but we have a device in the demo batch that was previously empty.
So it's added it.
And this is our unique identity. You can add them manually if you don't do this provisioning process, but it's just another couple of steps. So, if we look at our COM port, as the Rainmaker, we have now flashed our device, and it's going to be running the initial enrollment firmware, and it's going to be trying to connect to my Wi-Fi, but my hotspot's turned off. Q. Screen is not working properly. reset.
So the QuarkLink also programmed all the Wi-Fi details that we put on the screen into the device. So now the device is not talking to the laptop; it's now talking over the net to the QuarkLink, and it's trying to find out what it's supposed to do. So it's enrolling onto the QuarkLink.
This is the AEF, yeah. So if I just disconnect that, and we can scroll back, we can see the boot process. Here we go. This is from reset. Ooh. We've got the partition table, verifying signature, secure boot is enabled, keys have been set, and somewhere we'll see the Wi-Fi details there, Crypto Quantique Frank, and it's then going to try and connect and enroll to our device. My URL is called Demo2 QuarkLink. You should see that in here. And then it's just looking for firmware update. So this device now will just sit there spinning, looking for a firmware update. It's been enrolled, but doesn't know what to do. It's only got the initial enrollment firmware. So if we
refresh
go,
that screen, Keith. Refresh the QuarkLink screen to see it enrolled.
that's not enrolled to
Not enrolled yet.
MQTT yet.
All right.
It's enrolled to QuarkLink, but it's not involved to our IoT hub, which is what that's telling us there. So if we go to our batch, remember there was if we edit the batch settings, there's a firmware. So we want to give it some firmware to run. I've got some that's already loaded, but we're not going to do that. We're going to add some new firmware first. So go to the firmware tab. We can see our firmware there. We've got some signed there for the M5 stacks, and then we've got a blue and a green, which is going to change the colour. We're going to add a new one, so we're going to add some firmware. We're going to call it demo firmware. We're going to sign it with my provisioning key, which is the correct key. We're going to give it a description, and then we're going to upload the firmware here. So where do we get that from? Can't see the top of my screen. We're going to go to the Crypto Quantique GitHub, and we're going to download a pre-built binary. We're going to download the green one. This is a public repository. There's source code is available, and there's also the pre-built binaries. So we're just going to download that. Aren't we? There we go. Then we go back to QuarkLink, and then we just drag and drop our firmware in there and upload it. Firmware's been loaded. Save that.
So this would be firmware that you guys would add your app to, because the source again is in GitHub.
So now we have our demo firmware. Page refreshes. You can see our device is scrolling away. If we go back to our batch, because we're running out of time, there.
We lost internet.
It says no.
Your hotspot died.
It's on the main Wi-Fi. It's on Hardware Max.
The demo gremlin.
Demo gremlins have got me. You see our device here is just rolling around trying to get firmware. It's connecting to QuarkLink, saying you can see certificates going past. There's the end of one there. Authenticating itself with the QuarkLink, but it's not getting any firmware because nothing exists. Come ideally, we go into our batch and we pick that firmware we just downloaded and signed, and then the device would come to QuarkLink and say, oh, I need new firmware. And it downloads it, takes a couple of seconds, 20, 30 seconds, and then reboot, and the colour would change on my ESP32 to green, I think I downloaded.
We just lost the Wi-Fi over there.
But Wi-Fi is gone. So.
Okay.
Come by our stand,
Come on
and we'll try
stand.
again.
Put it on a phone. We was doing quite well then.
It was going
Till
so
the-
well.
The demo gremlin came along. So yeah, this is just to show you that the tool, again, you can sign up for it today. It'll program your device securely, put all the keys in. It will allow the device to unroll onto the QuarkLink, and you can do firmware over-the-air updates with your firmware. These are just example firmware in it. You back?
Watch. Come on, get bigger. There you go. Let's start in the OTA. It'll take a few seconds. See, it's got firmware. You can't see down the bottom.
New update bit. All right, so it's found a new one. The new one we just sent.
Do that.
Here we go.
And then
And it's downloading it.
it'll be the longest 30 seconds of your life. It will.
So what colour's the LED at the moment?
Cyan out the factory.
Cyan. Okay.
Yeah, it
And
will be
it's-
green. And if we go to our IoT hub and look at our demo MQTT, we can display the MQTT data when it's published from our device. It's gone green.
It's gone green.
This should
Hey!
update.
Nice one.
Saved. But still come and see us because I can do it
Yeah,
again.
so you've got all the source code for an IoT product. You can program it with the tool, onboard it to MQTT. We could have done AWS or a database just as easily. And then you just upload your new firmware, save, and it will, on the next call, it will just download new firmware. It's really cool. 5 minutes for questions. Three? Oh, man. Question.
Can you do local deployment so it's faster, like through the cable?
No, it's we only do Wi-Fi connection at the moment. So no, there's not through like USB or anything like that or Bluetooth. It's always a connection to the cloud service through Wi-Fi because we want that TLS connection.
Okay, it's just it gets really slow, the development process, if you try to do it.
Oh,
like
if you're updating
yeah.
over the web. So the actual, when you're actually finally testing whether the air is working, yes, I suppose that is a fair point. But usually you'd be doing most of that sort of locally anyway, programming the device and checking that it still runs on your connection. But over the air, that's depending on what the network's like. So,
Thank you.
but nothing locally, no.
Do you support any continuous integration and deployment service?
Actually, my colleague at the back there would be able to answer. Anthony, would you be able to answer that?
We do, but one of the Ignite
Okay. So the question was, do we have an ECI? And we don't have that currently in the Ignite model, but in the higher end modules like Professional Enterprise, then we will be giving you that service.
So everything would be automated. Let's
Yeah,
say,
yeah. Yeah, everything's all API calls as well on this as well. So you could run it headless if you wanted to.
Super. Thank you.
My question was regarding the legislation that you talked about at the beginning.
Oh yes, yeah.
PSCI, the ETSI standard, they're both quite comprehensive, as you pointed out. Would you recommend a standalone certification scheme to show compliance with those legislation for manufacturers, for example?
That would be actually quite useful if they do that. If you talk to DSIT, I think they might have some ideas around doing that.
I do that.
Yeah, just contact them. I think they would be able to help you with that. Anything else?
What's the difference between the release and developer firmware?
Oh, right. So what we've done is enabled a lot more of the debug printf statements in the code on that one, so you could actually see. You know, the screen came up initially where it was configuring it and it was giving you data. It would just give you a ton more there. There's also logs in the provisioning process as well, so you can dump all the logs from that process. So if that didn't work for some reason, your local connection or whatever, then you could scan through it. So it's just more verbose, I would guess. But the release version, that's the one which, if you blow that into the device, you better keep up. Make sure you know which key you used. Okay. Thank you. Thanks very much. Come see us at the bench.